Hello, my name is Brandon. I'm going to be demonstrating a fourth grade math lesson with the standards of 4 point NBT.3, which is to use place value understanding to round multi-digit whole numbers. And I believe it's also in combination with 4.OA.1, which is to interpret and multiplication equation as a comparison. So let's see how we do here. So I hope you guys enjoy my lesson. It's a distance learning theoretical lesson, so good luck. Okay, guys, we're going to continue today to talk about rounding and how to use rounding and estimation together to make math more mentally easy. Okay, today we're going to be using two things. I'm going to require two things, you guys. One, I need you guys to get your whiteboard out, your dry erase markers for me, and I need your manipulative blocks, okay, because today we're going to be using both for our lesson. Okay, so the first thing is let's get our whiteboard out. Let's look at page 88. Let's look at problem number 6. Okay, problem number 6 tells us that 6 times 4, what's that number, guys? 479. Does anybody else yeah, 479. Absolutely. Place value is very correct. It's not that 479 is incorrect, but right now we want to talk about correct place value because that's what we're rounding to. So in this case, we're going to be rounding to the hundreds. Okay, so if I look at my hundred spot, I go 1 back, which is my 7, correct? Okay, so now, is my 7 higher or lower than 5? It's higher than 5, so I'm going to go ahead and round that whole number to 500. Very good. Okay, so now, some of us can do this in our heads, some of us I can't. I know some of you guys still are learning multiplication, so what I want to do is show you guys a couple of shortcuts or easy ways to mentally get this done. One is let's draw it out and let's make an array. Okay, so if I have 6 times 500, how can I show that? Okay, yeah, right. Each one of these blocks is 100. Okay, so if I have 100, 200, 300, 400, 500, okay, oh, but if I look back at my stack, we just don't have enough manipulative blocks. So I want to see you guys model it. Let's draw an array on our page here. Okay, so if I'm going to do that, I'm going to have to do it kind of small because this is going to be one that's written out kind of big. But this is going to be my 100 block. So if I know that that's 100, I need 1, 2, 3, 4, 5. Oh, that was 6. Sorry, guys. Oh, no, that was 5. I apologize. Okay, so you guys, please do this with me. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes. Well, yeah, if you know that 6 times 5 is 35, absolutely, like we've been working on, if you add your place value, add those zeros on the end, right? We drop them, we flip on the end. Yeah, we could totally solve it that way. But first, let's look at this. I want to kind of model it first. I want to see what you guys are understanding here. One more row here, guys. Okay, so if we take a look at this, I now have my 6 rows at 5 or 500, right? Because again, each one of these are 500s. So I could do this a couple of ways. I could count them all up, right? So if I have 5, 5, 5, I could add them all. I could skip count, right? But let's look at it multiplication-wise. If we look at this, and I have 6 5 times, what was 6 times 5 again? Yeah, 35. That is absolutely correct. So if I have 35 here, what's missing? Yeah, my 2 zeros, because what were we working in? We're working in the hundreds place value. Absolutely correct. So I'm going to drop those 2 down, and that becomes my answer, 3,500. Okay, so if we were to count them all, and we were to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that's right, they're hundreds. 100, 200, 300, 400, 500, 600, 700, 800, 900, 10, 11, 12, 13, 14, 15. Okay, by the time we get down here, we're going to get to 3,500. Okay, this is just a simpler way of doing it in your heads. Okay, any questions? Good. You guys are doing good. Okay, let's erase that one. Now the next one, if we look at problem number 7, this one we're definitely going to be able to use our manipulative blocks. However, I want to see you guys also put it on the whiteboard. I really like watching you guys draw it out. For me, it just helps to see what I'm doing right in teaching you guys the lesson. Okay, so let's look at number 7. So number 7 is 3 times 920. No, you're right. It's 92. Good, very good. Okay, we're catching that one. So the first thing is I want to make this a friendly number in my head. I want to get it to a power of 10. What am I going to do? Yeah, we're going to estimate and we're going to round. What number am I going to look to? To the 2, absolutely. And why am I looking to the 2? Where's this 9? Okay, what place value is that 9? Well, it's not in the hundreds. That was the last one. The tens place value, absolutely correct. This basically means I have 9 tens. Okay, so I'm going to rewrite this as what? 3 times, yeah, 90. And again, why is it 90? Is 2 closer? Yeah, it's closer to 0. Absolutely correct. So now, how can I model this? Okay, we're going to do that in 2 ways. One is going to be with our whiteboard. The second is going to be with our manipulative blocks. So let's look at our whiteboard. Now, the last one, we used this big chunk right here. That was our 100, right? Now, 90, is that in the hundreds category or the tens category? It's in the tens category, so I can't use that. But I can use this cool little dash right here, which means 10. That is my single mark, okay? Or that means just 10 whole. So if I have 9, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many times am I going to do it? Yeah, absolutely. 3 times. Let's do that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. So now, if I look at my array, I have 3 times 90. Okay, because again, each one of these dashes are 10. So I can either A, count all of my dashes. Okay. Oh, wait, I forgot. I'm sorry, guys. Show me with your manipulative blocks. Show me what you guys, how would we use that? Okay, right. Yes, so these are in stacks of 10 or stacks of 100. Okay, but do we have 100? No, our number was 90, right? So what I do is I look at this and I'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And how many do I need? 9. So let's count up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I take that top one off. And now I know I have a stack of 9 tens or 90. Okay, and how many of those did I need? I needed 3 of those, correct? So if I did 3, 1, 2, and 3, there's my 3 whole groups of 9 tens, which gives us 90. So either way we go, we could either count our blocks, we can count our dashes, or we can do a little bit of multiplication and remember our powers of 10 and our place values, okay? So we are working in the group. Good. It's going to be, yes, okay. So now, let's multiply that out. What is 3 times 90? Or what's 3 times 9? Yeah, let's talk about our 9 trick. Good. So what's 1 less than 2? Or 1 less than 3, sorry guys. Yeah, it's 2. 2 plus what gives us 9? Yeah, 27. Okay, so you guys remember that trick. Whenever we do this, when you look at what 9 is being multiplied by, go one number less than it, and what is added to make 9, and you will almost always get your multiplication right. Okay, actually, you should always get it right if you're doing that. So now I have 27, but is that it? Is this only 27? No, it's not, okay? When I count this up, if I count these, if I count this, this is 90, 90, 90, 90, 90, 90. Okay, so it's not going to stay in the tens. We're going to end up having to go and drop our 0, drop that down. And sorry, guys, I messed up. That was my fault. What I meant was 10, so this is going to be 90. and 90. So if we have 9 and 9, that's going to give us 180. Plus, we have that 90 right there, right? So if I drop that underneath, yeah, I want you guys to show me too. Yep, yep. Okay, good. So now we know that 3 times 90 is going to give us 270. And if you guys were to go through and count your blocks that same way, you're going to get your same answer for that. Thank you for this demonstration. I hope you guys enjoyed my quick lesson. Please feel free to give me good constructive comments, and thank you guys.